Optical fiber.
Okay, now today we are going to learn something about optical fibers. It's the basics of photonics. So, photonics is transferring of, uh, well, it's basically transferring of information using optical fiber using light. So, before we do this, let's just concentrate on how do we transfer information. Say if I'm talking, uh, say if I'm talking on the phone, how does the person on the other side of the phone line, on the other side of the earth, hear me? Okay. Now it all starts with a simple circuit, with a variable resistor with a resistance. However, in this case, the difference is the variable resistance here is a microphone. So the idea how they make it is it looks something like that. So when I talk to you, when the sound is traveling in the air, okay, the sound actually pushes the air forwards and backwards. Okay? So the way they turn a microphone to a variable resistance is they do something like this. So imagine if I have a wire on both sides, they put some material in the middle. Okay? So what's happening is this material in the middle, as I talking to the microphone, this material in the middle, they sometimes go down, vibrates. Okay? It vibrates up and down, okay, due to the sound. Okay? The vibration go up, sometimes it vibrates up. Because when I talk, the sound travels in the air. As the sound travels in the air, it pushes the air particle moves forward and backwards. Okay? Thus, this material moves forward and backwards. So when electricity goes through it, what's happening is the resistance of the material, okay, changes when it moves forward and when it moves backward. Okay, so let me just write it down. So the resistance of the material changes. Okay, that's what's happening inside our microphone. So imagine if I have current flowing in this circuit all the time. Okay, so when I start talking, okay, the resistance changes. Okay, if the resistance here changes, then if I connect a voltmeter, say if I connect something, we can basically convert what the sound into a signal like this. Okay? You see those electrical sound signals like that, because when I'm talking, the thing in the microphone moves backward and forward, thus the resistance of the microphone increases or decreases, and if I record the voltage across here, I record a signal like this. Okay. Then what's happening is the recorded signal is sent to far away, okay, by telephone wires. Okay. So on the other side, okay, if the signal can be connected to an amplifier, then connect to a speaker. Okay. and you can hear, people can hear what I'm talking about from kilometers, 10 kilometers, 100 kilometers away. Okay? That's how does basically how does signal travels. Just remember this. This is the basic concept, okay, of transferring a signal over long distance. Okay? So ancient times we use copper wire, just like your telephone. We use copper wires to transfer the signal, and this caused a problem. The problem is called attenuation and the skin effect. Okay? So it only happens in copper wires. Now, the attenuation is a fancy word for loss of power due to resistance. What happens in the copper wire? The copper wire has a resistance. So when electrical signal travels through it, the further it travels, the more the further it travels, the more loose it is. It will lose its signal. The signal becomes faded because the copper wire has resistance, and over a long period of distance, the signal becomes very fake and hard to recognize. Then when it travels to the amplifier, 10 kilometers away, the amplifier amplifies it, then we can't hear a clear sound. Okay? This is called attenuation. Okay? Now, another problem is the skin effect. So what's happened is in copper wire, the AC current, the signal is basically AC. Okay? The current density near the surface of the copper wire is higher than the current density in the core. So the other word is, what's happening is the signal on this end, after it travels to the other side, it will be different. It will be due to this effect, the signal will be different. And then again, we cannot hear a clear sound. Okay? Of course, this is just a background knowledge. Of course, the scientists in the early 20th century, they did a lot of things to minimize those effects, and they were quite successful. And but then we found a better way. We found a better way to transmit signals over long distance by using optical fiber. Okay. Now let me explain what is optical fiber now. Okay, an optical fiber is basically a plastic rod made of certain type of plastics. Okay. So they design it so the light can travel through it. So when light, you don't have to know the detail of it, but just a basic explanation. So when light coming through a optical cable, it bounces around in the cable, and it travels to the other side without any loss. So the idea is, if you bend an optical cable, if you have a cable, you bend it over like this. Okay? And if the optical cable is huge enough, okay, if you can look into it, if the cable is big enough, if you can locate into one end of the cable, you can see exactly what's happened on the other side. That's the beauty of the optical cable. So yeah, the important thing is the light can travel through the optical cable no matter how it bends, no matter how it travels. And light is faster, and it doesn't lose the signal. Okay. So with this piece of equipment, we designed an optical system to transmit signals. Okay, with yeah. Now what's happened? What we designed was, say if we have a variable resistance and we have a delta. Okay, and in this case, what's happened is, say if the variable resistor again it's a signal input. It may be the microphone, it may be a computer. So say use a microphone. So when I talk to the microphone, the resistance of the variable resistor changes. Okay. Then it creates then the voltage across the LED, because it's a light emitting diode. Okay. The voltage across the LED light is different. So the LED light shines, and the light intensity sometimes be higher, be lower, just depend on how they designed it. Then we have a signal. Okay. Yep. Then we have an electrical signal as was happened before. Okay. Now, the beauty here is this time we connect the LED, we connect the light emitted from the LED to an optical cable. Optical fiber. So the optical fiber travels kilometers away to reach to its destination. And on this optical fiber, on the destination, there is a device called light-dependent resistance. A resistor its resistance changes due to the light intensity. Okay, so this is just a simple design of the whole system. Light-dependent resistor. Okay. So when the signal travels to the light-dependent resistor, then the resistance of the LDR changes. So in this case, okay, if I connect the output of the LDR to an amplifier, then I connect the amplifier to a speaker. The speaker is able to broadcast what I was talking about there. Okay. So in this way, because we use the optical fiber, so there will be no, it's very efficient. Okay. Say if I compare with what's happened before, compare with using of metal, copper wire, we don't have the attenuation and the skin effect problem. The signal was clear and better. So this is the importance of optical fiber, and it will be in the exam. Somehow maybe the examiner asks you about the optical fiber, but just have a read. Okay, this is what that's why it's important. That's why we're using them instead of copper wire now.